We continue the aspects of application of trigonometry to angles of elevation and depression. Here we'll be looking at example 3, where we are given that from the top of a cliff, so that means the cliff is standing vertical, and the word from here. So this proportion from is very important when it comes to elevation and depression and problem from bearing. It determines where the angle is. They say from the top. That means this is the top of the cliff. So we have, when the person has not viewed anything, this is the high level of the viewer. So the cliff is, of course, 20 meters above the horizontal ground. This is the horizontal ground. And a boat can be sighted at sea, 75 meters from the foot of the cliff. That is, if the foot of the cliff is here, the boat will be here. This is the boat. This is the boat. So which is a 75 meters away from the foot of the cliff. So since the viewer is on top of this cliff here, when the viewer has not viewed anything, we said this is the high level. And by the time the viewer is now has to depress, since the height of the viewer is higher than the object being viewed, so we depress the high down like this. So that's the high level. The angle is always between the original high level and the new high line. So which is this now? And the angle, we are not even giving the angle, we can call it theta. So since the cliff is standing vertical to the horizontal ground, we have 90 degrees there, and this produces the right angle triangle, which we can solve using the idea of trigonometry, SOHCAHTOA. Now, one important thing is that angle of depression will later converge into being an angle of elevation. Why? Because this regional high level was parallel, or is parallel to the horizontal ground. So in this case, we now see this high line as transversal between the two parallel lines. So for those of you who have not watched the video on angles and lines, go to the channel and watch it to see. This is what we call alternate angle. The angle here will migrate to this place by means of alternate angle theorem. So we have it this way. That means whatever you get for theta here is what the angle of depression there will be. And to get this, opposite to this angle here is 20, and this angle here is adjacent. So invariably we're using tangent here. That will now be TOA. So tan theta equals to opposite, which is 20, over adjacent, which is 75. So we have tan theta equals to, use your calculator to convert 20 divided by 75 to decimal. We have 0.2667. So from there, to make theta the subject, we introduce the inverse of tangents that will help us remove this tan away, and you introduce it to both sides. And the inverse is called arctan. Arctan on this will remove this, and we have theta left, equals to introducing arctan, take arctan on both sides. So we have 0.2667. So from your calculator, press shift and press tan to bring out arctan. Then press the value you want to give and click on the equals button. So arctan 0.2667, and that should give us 14.93 degrees. So always check back on the question if you are asked to approximate the angle or not. But here they just say find the angle. So we may not really want to approximate it, but if we want to do, you check for degree of accuracy from the question. Since in the question all the angles are given to two significant figures, I mean all these values, the size here are given to two significant figures, so I can express the angle in that to conform. So that will be to the nearest whole number here, that's 15. Approximately 15 degrees. 15 degrees. And that's the angle of depression of the boat from the top of the cliff. We quickly, without wasting time, we move on to the last example on this concept. To solve this problem, we are given there are two observers, P and Q. Their distance apart is 15 meters, and both of them observe a kite K in the same vertical plane and from the same side of the kite. The angle of elevation of the kite from P and Q are this. So what we do is that since the two of them observe a kite in the same horizontal plane, in the same vertical plane, and from the same side of the kites. Let's say this is the top K here. This is the top K here. But the angle they use this time around, that means they are at lower level from where K is located. Now, the two observers are P and Q, and they are 15 meters apart between each other. The thing is that if two observers will view this one, which one will have the larger angle? Is it the one further away from this kite or the one closer to the kite? If we look at it, the closer you are to a particular pole, if you want to view the top of the pole, the more the angle, because you need to stretch your head up well before you view it. But if you are viewing it from afar, it is more convenient, and you just need a very small angle, because you barely even raise your head before you view it. So that means if we have P and Q as they give us, we have P here, we have Q here. Q is closer to use larger angle, while P is further away from this kite. And that one will be 35, the smaller angle. So this one is a 45 here. And we have this. And P and Q are 15 meters apart. 15 meters apart. So let me call this place, let me label it A. So, and here we call it X. X is X. If you look at this, for us to solve this, we have two triangles there. We have two triangles. The first one is the smaller is triangle KAQ, where you have KA is, let's call it H, and here X, because that's what we have to find, height of the kites. So we have 45 degrees here for it. And the second right triangle, because we are dealing with right triangles in this concept. So this one is K, this one is A, this is H, and this is a point P. And P from A, P to this A, the distance is this X plus this 15. That is X plus 15. That's the value for PA. And the angle here is 35 degrees. So it is these two right triangles that I want to apply our SOHCAHTOA to deal with. So in the first triangle, we can see that tan 45 equals to H over X. So tan 45 equals to H over X. If you press calculator for tan 45, it gives 1. 1 equals to H over X. And when you cross multiply, we have H equals to X. And we can name this equation 1. Also consider the second triangle, tan 35 equals to H over X plus 15. Tan 35 equals to h over x plus 15. So this implies tan 35 from your calculator, tan 35 will give us 0.7. 0.7. So it is actually 0.7002. So but let's take 0.7 there. Do is press the values of trigonometry to 4 decimal places because I have 2 zeros. That's why I just ignore it. So we have x plus 15. We cross multiply here and we make h the subject as well as we have in equation 1. So we have 0.7 multiply x plus 15. And we can conveniently call this equation 2. If you look at equation 1, h is the subject, h equals to this. In equation 2, h equals to this. That means we can equate equation 1 and 2 for h such that this x, the value of h here, will be equal to the value of h here. That is, we can have x equals to 0.7 into x plus 15 and solve this out for x. 0.7x plus 0.7 times 15. That should give us 10.5. So collect like terms, we have 1x minus 0.7x equals to 10.5. And from here, 1 minus 0.7, 1 minus 0.7 will give us 0.3x, 0.3x. That is x minus 0.7x, which is equals to 10.5. So to eventually get the value of x, divide both sides by the coefficient of x, which is 0.3. So 10.5 divided by 0.3 gives x equals to 35 meters. Now, since it is the height that we have to find, anytime you get any unknown like this, then substitute in any available equation to get the actual variable or letter that we have to find, which is h. But in this case, if you substitute 35 for x in equation 1, so h2, since x equals to h directly there, that means h2 is 35. H equals to 35 meters. So we have this answer. And you can see they said to the nearest meter. That means in the first place, this 0.7, I should have even written 0.7002. And by the time you approximate, the whole answer will still converge to 35 degrees. 35 meters. So this takes us to the end of the concept, elevation and depression. Do subscribe to the channel. Thank you.